All right, everybody, welcome to the Daily Space Weather. Talking about how Sunspot 2839 has appeared, Sunspot 2835 has degraded, and your independence, hopefully independent from nonsense, by doing things like watching the Smash News Network, least busted name in news. Here's the solar intensity gram from the Solar Dynamics Observatory. And here's Sunspot 2839 showing up unexpectedly once again. Another sunspot group appearing here in the northeast. So looks like a beta class sunspot. We'll analyze the magnetic field structure toward the end of the video. Sunspot 2838 has set. Sunspot 2835 has degraded a little bit. And I think this one's called 2837. This one looks like it's degrading as well. It looks like it's downgraded to an alpha class sunspot. Here's some more imagery from the Solar Dynamics Observatory. It's ionized helium. To show some solar flares, which occurred yesterday, we did a couple videos about it. An X-class solar flare occurred yesterday, the largest solar flare of approximately 4 years. Since September of 2017, we haven't seen a solar flare of that magnitude. Here's some more imagery. It's 171 angstroms ionized iron and the colorized magnetogram, also from the Solar Dynamics Observatory. Great imagery there. And let's zoom in at the northern hemisphere to see the sudden formation of Sunspot 2839 right here near my pointer. And let's continue on. Here's a diagram of the solar system. And we'll advance this 1 week. There's where things should be moving to in 7 days. The 10.7 centimeter radial flux is at 94 solar flux units. Here's a 1 year chart of that. That's from Solon.info. The black line is the 10.7 centimeter radial flux. The radio output of the upper chromosphere and lower corona, the most proportional data set to sunspot number. And look at the precipitous uptick in sunspot number. Expect to see the radio flux rise in the coming days as well. And we're not expecting any geomagnetic unrest or solar geomagnetic storms. There is a KP3 forecasted here from a rather weak system of coronal holes. Late in the day tomorrow and early in the day on Monday, July 6th, Tuesday, July 6th. We're seeing a huge lull in earthquakes here. Only 1.7 magnitude earthquake over the past 90 days. If you're in an earthquake-prone zone, please have a plan. Earthquake droughts end in large earthquakes, and we're seeing a massive earthquake drought in 7 and larger magnitude quakes. So we saw a number of quakes here in the 5 magnitude range. Again, nothing over a 6. Nothing even at a 6 magnitude. There was a 5.7 at the southeast Indian Ridge there, to the southwest of Australia. Also a 5.2 at Indonesia. 4.5 at depth near Japan. A 5.7 in the Owen Fracture Zone region. I think that was the largest quake of the past 24 here. Oh, no, I think there was a 5.9 in South America. Anyway, that one's southeast of Saudi Arabia. Also a 5.1 in that same area. The Band AC saw a deep quake at 4.6 magnitude, 119 kilometers depth. I stand corrected. There were 2 6.0 magnitude quakes here. One at Chile and another one at Chile, both quite close to each other, it looks like, showing up as the same spot on the map there. And this one looks like it did some damage. Here's the location of this 6 magnitude quake. Just off the coast there. So 2 6.0 magnitude quakes happening there, about half an hour apart there, 28 minutes apart or so. Let's go back to the list. As the 7 magnitude earthquake drought continues, there was also a 5.6 in southwestern Mexico. And continuing on to check out volcanoes. We're interested in what volcanoes are erupting. It looks like Telica back on the list. Let's start from the top. Mount Abiko, producing a 12,000-foot ash plume. Subanosejima exploded, unknown volcanic ash cloud over the Ryukyu Islands. Kadavar now back on the list as it explodes, produces a 5,000-foot altitude plume of volcanic ash. Fuego exploding, flight level 160, it's a 16,000-foot plume of ash. 5,000-foot plume of ash over Nicaragua as Telica explodes. Nevado del Ruiz in Colombia now exploding as well, producing a 22,000-foot plume of volcanic ash. Sangay exploding over Ecuador. 22,000-foot plume of ash there. Revenador volcanic ash not seen in satellite. Don't assume it's not erupting. Sabancaya in Peru exploding. Intermittent emissions of volcanic ash have produced a 25,000-foot plume of volcanic ash. And please do not pole vault the Nevados de Chilean caldera. Intermittent volcanic ash puffs have produced a 12,000-foot plume of volcanic ash as it explodes. Don't pole vault the caldera. It could be unhealthful. This public service message brought to you from smAshomash.com. So we saw a series of radio blackouts yesterday associated with, we've seen 3 M-class flares here in the past 24 hours and an X-class flare. These have the ability to cause radio absorption. So normally radio communications, they quote bounce and quote off of the ionosphere. They don't really bounce off the ionosphere. Those radio signals are absorbed and re-emitted by the material in the ionosphere. And when X-rays highly ionize that region, those regions stop reflecting radio signals as expected. That's how radio blackouts work. It gives you insight into where the sun is located over the planet, as the hottest spot is right at noon. And that's what we're looking at here. These are the radio blackouts associated with the recent M-class flare. So there's that M-class flare that just happened a few hours ago. Anyway, we call that the deabsorption region. It's the lower portion of the ionosphere, as those strong X-ray signals make it deeper into Earth's atmosphere. And most X-rays are filtered out before they reach the surface of the planet. We'll show you a diagram on that later. So here's the coronal mass ejection that was associated with that X-class flare. And you can see it is not Earth-directed. We're expecting that to miss entirely to the west. It did send some relativistic protons in our direction. There's the animation of that from Lagrange point 1 at the SOHO-LASCO C3 coronagraph. Sort of a double pulse there. And here's the GOES X-ray flux 3-day chart. So we saw an M-class flare, then an X-class flare, then another M-class flare, and now just this morning another M-class flare. And we don't see any coronal mass ejection associated with that yet. If one happens, we'll keep you posted. Here are the relativistic protons. We saw this little spike here. And that's an indication that it took only about 5 hours for some protons to show up. So those were traveling at relativistic speeds. So it takes 8 minutes for light from the sun to reach the Earth. These protons arrived in only about 5 hours. We assume that they're probably associated with this X-ray flare. And that's a normal thing. We've seen solar protons show up, relativistic ones that is, in as little as about 20 minutes. So traveling at a significant percentage, like 1/3 the speed of light, is a pretty fast series of protons. This event subsided quickly, not really a noteworthy proton event. The GOES magnetometer is going to continue to look spiky here over the next couple of days. And it's because there's a bit of a tug-of-war going on with the current sheet. Here's a visualization of that. So this Gong 2 data is derived from 51 ground-based magnetometers, as well as magnetometers on stereo A and stereo B. And by the way, these are stereo A and stereo B. There's A. That's a terrible A. There's A, and there's B. And there's a bit of indecision with the polarity of the current sheet at the earthly zone right now. I don't want to get too into the mechanisms of that, but there's the data. Keep in mind it can change suddenly with no warning, the same way sunspots can appear suddenly with no warning, as we learned in epic fashion, or some of us were reminded of in epic fashion, when sunspot 2838 appeared on the northwestern limb and produced an X-class solar flare. Anyway, here's the line of sight ecliptic plane field plot complete with solar magnetogram. Sort of a 3D representation from our perspective here on Earth of the current sheet and its shape. And here's the line of sight coronal hole plot. Most coronal holes have largely dried up here, although we do see some here in the south and in the northwest portion. A little bit of a North Pole oriented coronal hole up there. We don't expect a significant coronal hole wind stream, as there aren't many holes in the corona. So there is the detected coronal holes and sunspot groups imagery. Sunspot 2839 is already a beta class sunspot, so we're looking at an increased probability of significant solar flares out of sunspot 2835. Despite the fact that it's degraded, it still does have one huge leading umbra there. And we'll be keeping an eye on sunspot 2839. Sunspot 2837 looks like it's degraded. It'll probably become an alpha class sunspot today, as it looks like its trailing umbrae of opposite polarity have largely evaporated, if not entirely. We'll take a look at that in depth later in the video. Global geomagnetism currently at a KP of 1. The K index, a measurement of global geomagnetism. Let's take a look at the real-time solar wind. And there's the real-time solar wind data, fairly uneventful here. Current conditions are about 4.2 protons per cubic centimeter for the density. Solar wind speed only 349 kilometers per second. Basically solar minimum conditions, despite much greater than solar minimum conditions in terms of the radio flux and sunspot number. Here's the magnetohydrodynamic pressure of the past 4 hours. We don't see any major solar wind components coming in, so we're seeing a fairly homogeneous pressure here over the past 4 hours. I'll let this play through as it refreshed, and we don't want to edit the video to get it onto your screen as quickly and promptly as possible. And no major changes happening into the solar wind there. No major changes in induced magnetism on planet Earth. That data courtesy University of Michigan. Here are ground magnetic perturbations. For all of you who are very, very scared and spooked about geomagnetic excursions, here's a little tidbit. Geomagnetic excursions are orders of magnitude more likely to end in geomagnetic normalizations than they are geomagnetic reversals. Geomagnetic reversals are extremely rare and separated by hundreds of thousands of years. Anyway, there's 4 hours of data, not many ground magnetic perturbations there, geospace delta B. Now, we do regularly stream live to Twitch, by the way. Twitch is a fantastic live streaming platform. You can check us out there, twitch.tv/smAsho. We'll actually make a couple of live streams there today. Many of the videos that we host on YouTube are actually originally streamed live to Twitch. Again, twitch.tv/smAsho. They've got a great mobile app which will alert you to our streaming. If you're viewing the videos on BitChute or anyplace else, make sure you subscribe over on YouTube. Thanks to our new and loyal subscribers over on YouTube. Don't forget to check our playlists as well, youtube.com/smashamash/playlists. And if you're new to the channel, don't forget to press subscribe. And cheers. Congratulations on finding that our channel exists. We are also on BitChute. And we're on Discord, and we'll be including invites to Zoom calls on our Discord chat later. We did it yesterday for our call with Eugene. We're also on Patreon, patreon.com/smashamash. Thanks to our patrons. We'll be updating our Patreon credit crawl here in a day or two. Thanks again, patrons. And for you non-patrons, our patrons receive all kinds of alerts that nobody else gets to see, long before anybody else gets to see it. Patreon.com/smashamash. Thanks to our newest patron. Thanks for becoming part of the Smash team. Also, welcome everybody to the Neo Renaissance for watching the videos, as things like astrophysics and cosmology are in the process of being rewritten. Thank goodness, because there have been some issues. And there are some answers to the hard questions coming out these days. Thank goodness. If you click on this little arrow here, you'll see the rest of our social media. There's the link to our Discord chat. And we'll be inviting people to join on Zoom calls in future videos. Yesterday's test was more than successful. Don't forget to check yesterday's Daily Space Weather Supplemental video starring Eugene the Philosopher, our pal from Belarus, Eugene Bagashov. If you click on smAsho Store, it'll redirect you to this site, our Redbubble shop, where you can find this product, the Mansa shirt, since making America not suck again is up to you. And nothing says don't run me over or shoot me like a blaze orange piece of clothing. Now, I do have newly found faith in the U.S. Why? Because of appropriate distrust of the media. So here's a Reuters poll result, and I'm going to let this slowly scroll here. So you see Finland is quite trusting of their news media, as is Denmark, where like 59% have significant trust for the news media. Now, Greece is quite distrustful, and so is France. Hungary and Slovakia also quite distrustful of their news media. Check it out. Who ranked the lowest? Wait for it. You may be surprised. Taiwan's also very low. Gee, I can't imagine there being any propaganda in Taiwan. The U.S. showing up the lowest on the entire poll, and it's a large poll with a large representative sample, by the way. Thinking about news in general, do you agree or disagree with the following statements? I think you can trust most news most of the time. Less than 1/3 of Americans think they can trust most news most of the time. Thank goodness for that. Thank goodness for that. And we would invite you to be independents of nonsense on YouTube, on CNN, NBC, ABC, CBS, Headline News, CNBC, and all over the, quote, mainstream and, quote, media. Again, congratulations on surviving a global pandemic so far. Thanks for surviving a global pandemic so far. Thanks for surviving a pandemic of propaganda, nonsense, and fraud so far. And congratulations on finding our channel once again. This Reuters poll gave us newfound faith in the survival of the United States. Today's cosmology segment will be integrated and short. We picked a random number. It was number 4, which coincides with quasar B0016 plus 73. And here it is in optical. It's quite dim. Here it is on the 2 mass. That's infrared light. And this galactic core has one of its jets oriented directly toward us. It's quite distant, it looks like. But there it is in infrared. It coincides with an object over at the Neil Gorell Swift Bat X-ray Observatory. Again, quasar B0016 plus 73. That's entry number 4 of 1,050 objects at the Swift Bat Hard X-ray Transient Monitor. The Burst Alert Telescope. Next, an article about electron capture supernova. Now, I think it's a ridiculous and nonsensical idea, but there's an article about it on SciTech Daily today that you may want to check out. If you're very, very scared and spooked that the sun is going to murder you, maybe this is one of the mechanisms by which the sun could murder you. Yes, it's when a white dwarf starts to collapse under its own gravity because it, quote, runs out of nuclear fuel in its core, end quote, and then presses electrons into the core of nuclei at the subatomic level in its nucleus and then explodes because reasons. So we've never seen a star born or die, but one of the other a third type of supernova allegedly discovered, an electron capture supernova. And I'm going to let the article scroll here in case you'd like to read it. Feel free to pause the video. We'll be here when you get back. Also, don't forget to check our other cosmology segments. We've got a couple hundred of them at youtube.com/smashomash/playlists. Anyway, we don't see any supernovae that appear to destroy stars. Supernovae nebula tend to have stars at the core of them. And there's no indication that stars die or are born. We've never seen it happen, but there are lots of theories about it. Just like there are lots of theories that somebody built faces out of rocks on Mars. Now, if you view this from a different perspective, it looks absolutely nothing like a face, as this has been overanalyzed. And let me read some quotes about this astronomy picture of the day. You can find it yourself at apod.nasa.gov. And wouldn't it be fun if clouds were castles? Wouldn't it be fun if the laundry on the bedroom chair was a superhero? Wouldn't it be fun if rock mesas on Mars were interplanetary monuments to the human face? Clouds, though, are floating droplets of water and ice. Laundry is cotton wool or plastic woven into garments. Famous Martian rock mesas, known by names like the face on Mars, appear quite natural when seen more clearly on better images. Is reality boring? Nobody knows why some clouds make rain. Okay, I'll stop right there. Nobody knows why some clouds make rain? Are you deranged? Anyway, that's the NASA astronomy picture of the day, apod.nasa.gov. That's today's cosmology segment. Let's get back to the daily space weather. And we needed a little break to talk about cosmology before returning to the local environment. So electrons can charge satellites. Electrons surround planet Earth, and they give us insight into Earth's magnetic field. Here are the charging hazards. We see none. Here's the here's me learning to speak English again. The relativistic electron chart over the past year from Solon.info. Here's the 3-day chart of the electron flux. Nothing to write home about there. Moderate levels. And here is the forecast model. The forecast from NOAA is for additional moderate levels. Here's the total electron content forecast showing you the entire air column. We do see some high levels of electron flux here over northern Africa. And some slight anomalies here, a bit of chaos happening, but a fairly organized setup. We're seeing some high levels of electron flux in the southern Indian Ocean here. Some minor anomalies there in the southern hemisphere. I'll let it play through here before showing you a diagram of the Earth's Van Allen belts to give you some idea of altitudes and context and where satellites are located. Here's that diagram. Feel free to pause the video. Next, we'll look at the ionosphere, which is located at about 300 kilometers of altitude, at least the F layer. Here's the D layer that we talked about earlier. This is the layer which radio communications are, quote, reflected off of. Technically, they're absorbed and re-emitted, but that's the layer that we're talking about when we talk about the de-absorption region. And sometimes X-rays make it all the way down to the D layer. As you can see here in this central portion of the diagram, that is the penetration of electromagnetic radiation. Here's vibrational frequency in the ionosphere, and it's looking a little bit less anomalous last I checked. We'll give it a minute to play through. You're looking at an entire day here at 2 hours per second refresh rate of vibrational frequency at the F layer at about 300 kilometers of altitude, one slice of the atmosphere. The total electron content is the electron content of the whole air column. This is one narrow slice in vibrational frequency. Here's the latest image. That's 10:30 Universal Time. Things looking pretty normal there at the F ionosphere layer. And we just streamed our meteorology segment live to Twitch. It's time for bonus features for the Daily Space Weather video. If you haven't checked out our meteorology segments, you can find all of our playlists once again at youtube.com/smashamash/playlists. So here's the latest hydrogen alpha imagery from El Teide, Spain. And you'll see sunspot 2839 grow right there. Here are additional bonus features. Here's the GOES 16 SUVI thematic map. Again, the likelihood for major solar flares is still there, folks. Sunspot 2835, this one down here, is quite huge. It still does have opposite polarity umbrae, and this one appears to be beta class as well. Here's the latest high-res colorized magnetogram. I just pressed refresh. Here is the intensity gram, and we'll take a zoom in here of sunspot 2839. There it is in intensity gram. And here it is in colorized magnetogram. As you can see, it's already a beta class sunspot. This thing appeared quickly and has the capacity to produce solar flares. Here's Sunspot 2835, which has degraded a little bit more since we did show prep. There's the umbra. It is still beta class, as we do at least see some North Pole umbra like this one right here. And last but not least, here's 131 angstroms ionized iron, one of the many ionized iron spectral states shown by the SDO. 131 angstroms, like 94 angstroms, takes 10 images per minute instead of only 2, which is part of the reason why it looks so good when we see major solar flares. I would also note some plasma moving around up here. That is associated with the coronal mass ejection we showed earlier in the video. Anyway, thanks for tuning into the Daily Space Weather. Be independent. Have independent thought. Press like and subscribe if you enjoy the content. Tell your friends and foes. Press the share button. Tell us what your favorite social media is in the comments. And may that solar wind be at your independent back.